Sorry guys, for being late. I end up restarting my PC because Zoom is not coming up properly. So let me set up the YouTube session and then we'll get started. I'm almost there. It might take another minute or so. I hope everyone can see my screen and listen to me clearly. Uh, if there are any issues, just let me know. Again, still it is not giving start broadcast option here. I don't know why. Just give me a moment, okay? I don't know why it is causing issues here. When I'm doing from home or anywhere, it's working fine, but for some reason, it is causing issues here. Uh, Still, it is not showing the start broadcast option here. So let me do one final thing. If not, I will stop streaming on YouTube and I will be doing only the Zoom session. I don't know why suddenly it is behaving like this. I'm using Chrome this time. Probably it might be the issue with the browser. Hmm. Interesting. I don't know why it is not coming on air here. Everything looks good. Okay, that is fine. I will close this. I'll be recording only on Zoom. Okay, so I'm deleting this one. Now let us get started. Okay, so let me first confirm that it is being recording. Yes, it is being recorded. I will upload this video to YouTube so that you have the playlist complete. Uh, Let me close this and so today we'll continue on yarn. Yesterday we have spoken about the job life cycle, how the jobs are executed in yarn. Today we will be talking about scheduling. So first let us understand where scheduling comes into picture. Okay, so on a cluster you might have petabytes of data. Means there can be hundred nodes, 100 node cluster, 1,000 node cluster, and you might have petabytes of data with a few gigabytes or terabytes of memory. If you take the previous example, which I have shown as part of yarn capacity planning, we were talking about ten nodes. Okay, let me zoom in a bit here. Okay, yeah. So I think I was not sharing the screen. Now I am. So number of nodes 10. Okay, and RAM CPU. So RAM is 256 GB, out of which 245 GB is given to node manager on each of the node. That was the from the example which I have covered as part of the capacity planning. And CPUs each one have 48. Out of them, 4 are given to other purposes, and 44 are given to node manager. Okay. If you have 10 nodes and there is something called vCore multiplier, depending upon the nature of workloads which we are running, this vCore multiplier will change. It might be somewhere between 1 to 4. And let's take the example of whatever they have shown. It is nothing but 4. And hence, total cores are given are 176. And we have 240, sorry. Yeah. So we have 245 GB RAM and we have 176 cores on each node. As we have 10 nodes in the cluster, we have 2.45 terabytes of RAM. Okay, and we have 1760 cores. So at max, you can run 1760 jobs. Sorry, 1760 tasks to process the data. Task is the one which actually process the data. At max, you can have 1760. But what if at any given point in time, if you have jobs, again, a job will be divided into tasks. There can be n number of jobs running at any given point in time. One job might have to use 10 tasks, another job might have to use 1,000 tasks. Okay, so there can be a number of tasks that are, sorry, a number of jobs that are submitted at a given point in time, and m number of tasks might be required to process the data at any given point in time. What if the m is greater than this 1760, which is nothing but the maximum number of tasks that can run at any given point in time? We cannot just fail the job saying that resources are not available. It is quite common that m, which is nothing but number of tasks at a given point in time, is greater than the capacity of the cluster. Whenever that is the case, you should not just fail the job. You have to somehow manage them gracefully. Whenever resources are available, it should be able to pick those resources and the task should process the data. Okay, so that's what is called as scheduling. Someone has to take that responsibility of scheduling the jobs at any given point in time to handle the situation gracefully wherever the number of tasks that are required to process to serve the jobs at any given point in time is greater than the capacity. Okay, so that is called as scheduling. And there are multiple ways of scheduling. If you set up Hadoop cluster from open source platform, so Hadoop is a open source software and it is committed in an open source organization called Apache. Okay, Apache is the open source software foundation, and most of the open source softwares are managed by Apache. Okay, so and if you directly download the softwares from Apache, and if you set up your Hadoop cluster, it is called as plain vanilla installation. Okay, but in our case, we are using Hortonworks as a platform, and there are vendors like Cloudera, Mapper, etc. You can set up your cluster using vendors. The advantage of vendor distributions are they give tools to automate the setup process. Otherwise, what you have to do, you have to copy the binaries from Apache on each and every node, and you have to maintain them to keep everything consistent. Otherwise, you will not be able to use the cluster. For that purpose only, the distributions came into picture. To simplify the setup process, the distributions such as Hortonworks, Cloudera, Mapper came into picture. Okay, so let's talk about plain vanilla Hadoop and what is the default scheduler with plain vanilla Hadoop. The default scheduler is FIFO. What is FIFO? First in, first out. What is it related to? Queue. LIFO is stack and FIFO is queue. Okay, so the default scheduling mechanism is FIFO scheduler. What does that mean? Let's say we have 1760 tasks. We have the capacity of running 1760 tasks at any given point in time. Okay, from this example, considering 1 GB RAM is used or whatever amount of RAM is used, yeah, considering whatever amount of RAM is used, let's say the capacity is 1760. At time T1, so first let us create create names for the fields. First, I will be giving time, and then job, number of tasks, a total number of tasks required to process the data for a given job. Okay, and then processing completed. Okay, and also total number of tasks, total number of running tasks. Okay, so this is for all the jobs, not just the job which we are talking about. So let's say at time T1, there is a job called J1, and let's say it requires 17,600 number of tasks to process the data. Okay, which is greater than, even though there is only one job, the number of tasks that require to process the data is more than the capacity 1760. Okay, as it is 1760, let us add one more here. What happened? Okay. Let us have pending also. Okay, when it start, as there are no other jobs running, at time T1, there are no total number of running tasks. Just before the job is submitted. Okay, so it is 0. When the job is submitted, the pending will be whatever is in processing plus completed. At this time, completed is 0. Okay, once the job is submitted, as the capacity is available, all the capacity is taken over by this job. Okay, so 1760 tasks will be processing and others will be pending. So in this case, it will be equal to C12 minus E12. So 15,840 tasks are in pending state, 1760 are in processing and completed as 0. Let's say T2. Again, there is only one job. There is no other job submitted. Okay. Let's say out of this 1760, 1000 are completed. Okay. Processing will be still 1760. Right. And pending will be number of tasks is still 17,600. And total number of running tasks just before this thing will be 1760 only. Sorry. Just before the, yeah, you can ignore this. We don't need to set this for now. Okay. So as of now, 1760 are in processing, 1000 are in completed, and the pending will be, what happened? It will be E13 minus F13. 14,840 will be pending, 1760 are running, and 1000 are completed. Let me use the same formula here also. Okay. So like that, the job will be continue to run. Now at the same time, T2, when this is happening, let's say there is one more job came and it is J2. And let's say it requires only 10 tasks. Okay. So as we are using first in, first out, whatever job that comes first, until it go to that level where the tasks that are being completed by that job preempt the resources to other jobs. Until then, no other job will be picked up. Okay. In this case, the first job which is submitted will keep on taking all the resources until the number of tasks, the number of pending tasks is less than the capacity of the cluster. So in this case, until the completed or number of tasks completed are more than number of tasks minus, sorry, let me phrase this way. Let me rephrase this way. Until the number of pending tasks less than the capacity, which is nothing but 1760, the first job will keep on taking all the resources. So T2 will be pending all the tasks that are required for job J2 at T2 will be pending. So all the 10 will be pending. Crossing will be 0. And completed is also 0. Okay. Now, let's say at T3, 1000 more tasks are completed. So 2000 are completed. Whatever 1000 tasks that are completed, all the resources that are released will be given to the first job in queue. So the J1 itself will get all those 1000, and hence the processing tasks for J1 will be 1760. And the pending will be, I just have to copy this formula. Okay, for this job, we need 17,600. And then I just have to copy this formula. Now the pending will be 13,840. Okay. And if you take the example of J2 at time T3, the number of tasks required are 10, pending will be 10, processing will be 0, completed will be 0. Okay, like that, it will keep on giving the resources to the first job, which requires more capacity than the cluster. And let's say at T4, let's say 15,850 are completed. Okay. And what will be the processing number? Uh, 17,600 minus 15,850. Now the processing will be only 1750. So the resources are being now the required resources to complete the job for job J1 is less than the capacity of the cluster. Now whatever resources that are released will be given to the next job. Okay. So instead of saying 15,850, let's say completed are only 15,841. Okay. Now if you say 841, 1,759 will be in processing state, and then pending will be in 0. As there are no more pending tasks, as everything is processing, and as the resources are released, now the jobs which are in pending state can take those resources and can start processing the data. Okay. So at T4, this is the situation of J1. Now at T4, the situation of J2 will be out of 10 number of tasks, 9 will be in pending, 1 will be in processing, and 0 will be in completed state. Okay. So this is how it will be at T4. As the resources are released, now the second job also will keep on getting the task to the task to process the data, or containers to process the data. Now at T5, let's say for job J1, which requires 17,600 tasks, it only 1,750 are pending, are processing, and let's say 15,850 are in completed state, and pending will be 0. And at this time, J2 already might be, whatever task that is started here might already be completed. So let's say completed is 1, then processing will be 9, pending will be 0, and number of tasks that are required for J2 is 10. Okay. Probably at time T6, for J1, out of 17,600, pending will be 0 now. Let's say still 1,500 are in processing state, and then 16,100 are in completed state. Okay. And then for J2, which requires only 10 tasks, 0 will be in processing. Probably all of them might be done, and the job should have completed by that time. Okay. So this is how the FIFO scheduler works. So whatever job started first, it will get as many resources as it is required until it is done. Only the required capacity, only the required number of tasks to process the data for that job is less than the capacity. The other jobs will be get their turn. Otherwise, they will be in pending state till that point. Okay. What is the drawback of this? Yeah. Even though some jobs are small, they might be critical. No. The point here you need to understand is, even though some jobs are small, they might be more critical than the other jobs that are running at that time. But they will not be done until whatever large jobs which are submitted earlier are completed. That is one severe drawback. Okay. And yeah, the priority jobs have to wait until the long running jobs are pending. So to address this issue, there are two alternative ways. Even though FIFO is default, we should never use this in prod. Either we have to use phase or capacity. Okay, FIFO is default in plain vanilla. Phase is default in Cloudera, and capacity is default in Hortonworks clusters. So depending upon the vendor, the default might change. That's what you have to. So with FIFO, there are very very little flexibility to change this behavior. That's where the phase scheduler and capacity scheduler come into picture. Okay, so what is phase scheduler? At any point in time, each and every job will get its fair share of resources. That's the logic behind phase scheduler. Okay, so let's see how it works. So this is the behavior for the FIFO scheduler. Now, if it is phase scheduler, at T1, there is a job J1. There are 17,600 tasks that are required. 1760 are in processing state, and 0 are completed. And let me copy this here. Okay, at T1, this is what is happening. Now let's say at T2, 10 of these things are completed, and also a new job came in. So 10 tasks of job J1 are completed. Okay, so pending will be 7. Pending will be whatever is completed plus processing subtracted from 17,600. So I will fill that information at a bit later point in time. Okay, for now, let's ignore pending and processing for job J1. Now, let's say you got another job J2, which required 10 tasks to process the data. Okay, and completed should be 0 because the job is just started. Now, as there are two jobs which are trying to get the resources which are released by the 10 tasks that are completed, both of them will get equal priority and equal share. Okay, so 5 of these 10 will be processing, so 5 will be pending at this time, and then only 1755 for this job will be in processing state, and then this will be 1500 835. Okay, oh, here I said 1000 as an example, but now I'm taking only 10 as example. So there is a difference between previous one and this one. Okay, so that's why you got only 15,835 as processing, and 1755 sorry, 15,835 are in pending, and 1755 are in processing. And for this job, 5 is pending, 5 is processing. Okay, at T3, if there are only 2 jobs, and let's say the second one is already done, so 10 is required, 0 will be pending, 0 will be running, and the job is completed. Now again, this one will get 1760. Let's say only 10 more jobs are completed. So 10 more tasks are completed here. So 20 will be 20 will be completed, and remaining will be in pending. What happened? It is behaving a bit weird. Okay, so now 15,820 will be in pending state. 1760 will be running because there are no other jobs, so it will get all the resources, and remaining are completed. Like that, it will keep on processing the data. This is with respect to phase scheduler. With phase scheduler, there is a concept of I forgot the term. Yeah, there is a concept of pools. So not only you can schedule like this, you can also create pools, multiple pools, and each pool you can give a priority. Which pool uh, should be more should be given a higher priority than others. Okay, so don't worry too much about these pools and all. For now, just understand the difference between how the jobs are scheduled using the default scheduler, which is nothing but FIFO, and then phase scheduler, and also I will explain about capacity scheduler. Okay, the difference between capacity scheduler is more like FIFO scheduler. Only difference is in FIFO there is only uh, one pool, and everything has to run in that. So if there are any smaller jobs, we cannot give higher priority to that and make sure it is completed in time. There is no way to do that. With capacity scheduler, what they have done is they create multiple queues. Okay, so you might have Q1, Q2, Q3, etc. And within each queue, the jobs will be run using FIFO concept, using first in first out concept. Okay, only difference is you have multiple queues now, and you can actually, while submitting the job, you can tell in which queue the job should be running, and within that queue, it will use the same logic as we have covered earlier. Okay, so now if you have smaller jobs and if you want them to be completed faster, you should use a different queue than the normal queue, and within each queue you can tell how much resources of the cluster should be given to that. So if there are three queues, again depending upon the nature of the enterprise you are working in, one queue might be getting 70% of the resources, and the other two queues might be getting 15%, 15%, or one queue might be getting 50%, the other queue might be getting 30%, the third queue might be getting 20%. So there will be some brainstorming sessions which will be happening between architecture team and the admin team, and they will decide what queues should be created and all those things. Okay. So to understand the settings with respect to the schedulers, you can go to Ambari, and the scheduling is relevant to YARN. So all the properties with respect to scheduling will be part of YARN configs. Okay. So here I am logging in as admin. You can go to configs. And then you can search for scheduler. What it is using? It is using capacity scheduler. Okay. And there is only one queue. So in our case, until even though it is using capacity scheduler, it is similar to FIFO only. Okay, until the jobs which are submitted earlier requires less capacity than the overall capacity of the cluster, the new jobs will not get its turn. Okay, because even though I'm using capacity scheduler, there is only one queue. In actual production clusters, there will be multiple queues. Okay, if you are interested to explore further, capacity scheduler comes from Hortonworks. So Hortonworks have better documentation with respect to capacity scheduler. You can actually search for Hortonworks capacity scheduler, and you can get some information from here. So you can see how to set up queues. They give a nice example. They provide picture. So there is a root queue. There is a root, and then there are multiple queues: support, engineering, and marketing. And for each of them, there's a I think they provide some percentage of resources. Somewhere there should be some properties. Okay, if you don't specify the percentage, each of them will get equal amount of resources. So in this case, support will be 33%, engineering will be 33%, marketing will be 33%. And again, you can create sub queues for them. In support, again, there is training and services. And training will get 50% of the 33%, services will get 50% of the 33%. Like that, you can have a hierarchy of queues, and the jobs will be scheduled within that queue. So whenever you submit the job, you have to tell in which queue it should run. Okay. Also, it gives a bit of flexibility about how to yeah. So you can read through this. You can see here leaf queues. Leaf queues means this is root and these are leaves. So you can read this, read through this. Leaf queues hold the list of active applications and schedules resources in a FIFO manner. Okay, so only difference between capacity and phase scheduler is capacity scheduler gives you flexibility to run multiple queues. That's the only difference. Nothing more than that. Okay, so that is about scheduling, and that's how the jobs will be submitted. Now, to just demonstrate a bit on this, just give me a moment. There is some issue with my terminal. Yeah. So now I am connecting to the lab. And also I'm connecting to Resource Manager web interface. So whatever I have demonstrated in the spreadsheet, that is what you will get when you click on nodes. Sorry, not on the nodes, but when you click on running applications. So if you click on running applications, you can see out of the available capacity, how much is being used by each of these things. So you can see that there are 8, 15, 19, 17, 20, 23, 26, 29, and 36. Okay, I can actually get these details here. So 36 out of 42 vCores are already being running. So now if I submit a job, I'll be getting only 4 tasks, around 6 tasks to process the data. Rest of them will be in pending state. Now if I submit 2 jobs, one after the other, which require, let's say, 270 tasks, my second job will be pending until the overall capacity of the earlier jobs, the required overall capacity of the earlier jobs is less than the total capacity of the cluster. Okay, so let us see that. I am running the same Hadoop jar command which we have seen yesterday, and I am passing 10 files, not just one file. So it requires 90 tasks to process the data, and I'm copying this and hitting enter. Okay, now if I refresh this, and go to application master, you can see 43 pending, 46 running. It is because the other jobs which we have seen earlier are completed. Okay, now, yeah, there will be some out of memory issues because we are trying to run too much for the cluster. That is fine. Now let me run in another session. So things will be changing all the time. So it's very tough to exactly showcase what is happening. Now I have given a different path. Let us see how many resources this job is using at this time. Okay, it already saying 19 pending and 29 running, 42 complete. Now you see it takes a bit more time to get the resources. By the time I submit the job, the required capacity for the existing jobs is less than the cluster. If that is the case, there will be some running tasks on this. Otherwise, there won't be running tasks. Now, if you look at this, there is it's not progressing. It is only switching between 1 and 0% because it's not getting the resources to process the data. Okay. Sometimes it might not even have the resources to create application master. If it cannot create the application master, you will not get any information like this. It will be only saying waiting or accepted, something like that. Some sort of weird message. Now it is actually processing the data because it got the resources to process. As the tasks related to the earlier jobs are moved to completed state and the required capacity for all the running jobs is less than overall capacity of the cluster, this new job started getting the resources. Okay. So this is about scheduling, very, very important from interview perspective, especially for a bit senior folks. At least you should know the terms, and it's very easy to understand. There's nothing complicated in this, and you should have good idea about how Yarn manages multiple jobs that are submitted at the same time. If the capacity required for those jobs is greater than the capacity of the cluster. Now it failed because it could not get resources for a very long time, and also my cluster is a bit in unhealthy state because a lot of things are happening at the same time. That's why it exited. Otherwise, it will be in pending state for a very long time. Okay. Any questions here before we move on to next topic? So Shiva, I hope your question is answered. Is there a way to force a job to run? If not, I will explain if you still have the question. Okay. Now let's move on to the next topic. So far, if you go to Ambari, we have actually get into so many details which are relevant for the developers. There are other things also which I have not covered, which are not relevant to the developers. It is more relevant to administrators. Okay, we have covered HDFS. We understood how to copy files, how to preview files, how to change permissions on files, etc. And then we spoke about Yarn. Yarn is nothing but a distributed computing framework, and you can either submit MapReduce jobs or Spark jobs using Yarn. You can configure MapReduce or Spark. We'll not be talking about too much about Hadoop MapReduce. You don't need to worry about it. You can claim that you don't know it at all in the interviews, as our training is more focused towards Spark. Okay, and now you have plenty of other services also, and you need to understand the relevance of these services. Okay, so when you actually so before making the statement, let me tell you what I'm going to cover for today and tomorrow. I will just scratch the surface of almost all the services. I will explain briefly what is Hive, what is Pig, what is HBase, what is Spark, etc. And then we will deep dive into Spark and a bit into Kafka at a later point in time. Okay, so today and tomorrow we'll be focusing on all these services at a very higher level. And then we will deep dive the most important ones, which are part of our curriculum, which are nothing but Hive, Spark, etc. Okay, so now let us understand the relevance of Hive, why Hive is required. When you copy data into a file system, especially the data which come from your applications, typically in most of the cases there will be a structure. Structure means almost every line in the data look similar. Examples are our orders, order items, etc. Okay, so if you take orders have 4 fields, and each field is separated by comma. So at least 70 to 80% of the cases have structure, and the industry, the most popular way to process structured data is SQL. Okay, and SQL is a proven technology. It's there for a very long time, and a lot of people, not only the developers but many other IT professionals are knowledgeable in SQL. Okay, so instead of using programming languages and processing data using programming language APIs, if we can actually process using SQL, then the development lifecycle to solve a problem will be much faster. Okay, for example, I have gone through database essentials and I have explained SQL quite a bit in detail. And one of the very advanced examples is analytics functions, if you want to get ranking. And another common and complex scenario is join. So using Java, if you have to join 2 data sets, it will take at least 200, 300 lines of code. With Scala, it is a bit simple, but with Java, it takes almost 300 lines of code. Even with Scala, it is not that simple. Okay, it takes some effort to write a join. But with SQL, you can just write it in probably 10, 15 words in 2-3 lines. Okay, the reason why SQL is simple is the complexity to actually perform the join is hidden from you. It is already provided to you because it is very commonly used use case in the while developing applications, and hence someone took care for you. You don't need to write the same logic. You just use a high level interface such as SQL to join the data. Okay, so the point I'm trying to make is, if there is a data, if there is a structure on your, if there is a structure for your data which is being copied to HDFS, and if you want to process that data, the most feasible way of processing that is using SQL. Okay, and the answer for that, the answer for SQL when the data is structured in HDFS is Hive. Hive will serve the purpose of writing SQL on top of structured data in HDFS. So how to get onto Hive? I will get into a lot more details with respect to Hive at a later point in time. But just to launch Hive, so the hierarchy is first you need to have HDFS, then you need to have distributed processing framework, and then you get Hive and all. These are high-level interfaces to simplify your development life cycle. Okay, so to set up Hive, if you are not using the our labs, administrators have to first set up HDFS, then Yarn. Along with Yarn, they have to either set up MapReduce or Spark, and then they have to set up Hive. And all these things have to be integrated. It's quite a bit complicated thing, but developers don't need to worry about it because admin team will give it for you. Once you have access to the cluster, especially to the gateway node, you can type Hive like this and hit enter to get onto Hive. Okay. And for now, I will only showcase how to create a table, how to load data into a table, and how to query, just to understand the similarity between Hive and SQL. And then I will spend at least 2-3 classes or even more to cover many nuances with respect to Hive. Hive is a very important skill with respect to big data and data engineering. Okay, so we'll be getting into details once we see through the overview of each and every service that is available on our cluster. Okay, so if you have too many questions, just hold on to those things for now. We will discuss about those things at a later point in time. So now, when I launch Hive, it connected to a database called default. Okay, and Hive is a multi-tenant database. Unlike Oracle, if anyone is from Oracle background, Oracle is until 11G, it's a single tenant database, which means there will be only one database per Oracle installation on a given server. Multi-tenant database means you will have the database software running, and you can create as many databases as you want in that software. So MySQL is example for multi-tenant database software. Hive is also multi-tenant. You can have as many databases as you want in one Hive installation. Okay, and here to list the databases, you can say show databases semicolon and hit enter. There are hundreds of them on our cluster because ours is a subscriber based platform. There are many users using the lab. That's why you see these many databases. But in production clusters, you will not find these many. There will be 10 to 100 databases, not more than that, not 5,000 for sure. Okay. So, but to list the databases, show database is the command. As there are many databases, to switch to a database, you have to use a command called use. If you want to create a database, you can say create database. In this case, I am saying bootcamp demo, and it will create a database for you. Once the database is created, you can switch to that by saying use and then the database name. And now you are switched to bootcamp demo database. In some cases, you might not see the database names like this. You have to override a setting, and I will explain that at a later point in time. So if you go to a project or if you have your own Hadoop cluster, especially those who are joining from online, when you launch Hive, you might not be seeing the database names like this. To see that, you have to set a property. Then only you will be able to see. And I will explain those things when we actually get into details with respect to Hive. Okay. For now, don't worry if you don't see the database name in your own environment. Now, to create a table, to list the tables in this database, we can use show tables. And there are no tables at this time. Okay. So to create table, you can say create table orders. Okay. So this is called as DDL. As we have seen in Oracle, we have seen how to create tables and all. So same thing here. If you are familiar with SQL, if you practice well, when I actually spoke about database essentials and covered Oracle in detail, you will be able to catch up these things very quickly. Okay. So next 2-3 days, what I would recommend is to refresh your database essentials. Go through the videos and try to understand as much as you can. Okay. And then hive is a very important skill. It's better you come up with questions. You compare hive with whatever you learn in Oracle, and then raise the questions. If you start raising the questions and if I start answering to your questions, then it will you will understand it better. Okay, just don't absorb whatever I'm telling. Think, compare with whatever we have seen as part of database essentials, and you should come back with the questions. Okay, so that being said, in this case, so if it is Oracle, how did we create the table? Let me go to Kaizen here. Yeah, I will fix this formatting and all anyway. So if you look at the create table command, this is how the create table is ran in Oracle. We have create table orders, and then we have 4 fields: order ID, order date, order customer ID, and order status. And here we have given the data types: integer, date, integer, varchar2, etc. And then we have primary key in the for the table, which is order ID, and then we close the bracket. So even the syntax for our hive tables will almost be same. You will start with create table command, and you have to give the field names, and you have to give the data types, and then you once all the fields are done, there are very limited support for constraints. Mostly we will not be seeing creating constraint and all in hive. You will understand when we actually talk about hive in detail. Okay, except for this part, most of the part is same. We can just copy this one if our if we want to maintain the same structure in hive, and then we can use Sublime Text or whatever editor we want. So we will not be having constraints. And also when it comes to data types, varchar2 is popular in only in Oracle. In all other databases, we use only varchar. Okay. So in this case, I'm using varchar, not varchar2, and we can create this table. On top of this, when you create the table, you need to tell the structure of the data in the file. So this is one example which you need to understand at this time only. So when I say create table like this and run in Oracle, we don't need to worry about how the data is stored internally. It is taken care by Oracle only. It is completely hidden from us. We don't know how Oracle stores data internally on the files. Okay, and hence we don't need to tell. We don't need to share the details with respect to structure of the table. But Oracle has something called external table. Okay, in external tables, you can tell what is your structure of the data, and you can put a file somewhere on the file system, and you can query using Oracle SQL. That is different from traditional table, which actually stores and managed by Oracle completely. Okay, similar to Oracle external table, if they as hive tables are like external tables, the hive will not might not completely might not have complete control on the data which is in HDFS. Whereas in Oracle, for typical table, Oracle will have complete control on the underlying data and files associated with them. But with respect to Hive, it is not the case. As there is a separation between your structure. Structure is nothing but this: the field names, data types, etc. As the structure and the data are not tightly coupled, we need to tell what our structure is. Even if you don't tell, if you just create table like this, okay, the reason why integer is not working is the corresponding data type in Hive is int, not integer. Okay, you need to understand these differences, and these differences will be there between all the databases. Already we have seen varchar. Varchar 2 is available only in Oracle. If you try to create the same table in some other database like MySQL, you have to change it to varchar. With respect to Hive, as Hive is not a RDBMS, the changes are a bit higher. Okay, so you cannot just copy paste from the existing databases like this. You have to understand those differences, and I will cover those differences at a later point in time. Now let me run this. Now the table is created. Okay, so to get the details about this table, you can run a command called describe formatted table name. Describe formatted table name will give the complete metadata of our table. At this time, the main thing which you need to focus is location. So this is where the data with respect to this table will be located in HDFS. Okay, and also if you don't use default structure of Hive, there will be something called field delimiter, etc. here. Okay, there is some default behavior, and it uses that default behavior for your data. It expects data to be in that behavior only, as per that behavior. After location, the second most important thing which you need to focus is file format, and especially this part. What is it? It is text. So this table accepts only the text data. It does not accept anything else. Okay, and text data means your file should have only alphanumeric characters. No other binary characters should be there. Okay, and then the default behavior is the default Hive expectations on your data is the delimiter is null character, but our data is delimited by comma. Let's say I want to create a table which is already in HDFS. Public retail BB orders, and let's say Hadoop FS hyphen tail. And you can see the data. Data is comma separated. Okay, but we didn't specify how the data is delimited while creating the table. Hence, it will assume that data is null character separated. Okay, so to store this data and query against it, we need to tell that our data is comma separated. With Oracle, typical tables we don't need to do that, but with external tables in Oracle, we have to do that. Similar to external table in Oracle, in this case, what we have to do is we have to tell how our data is delimited. For that, we need to use some additional clauses which are not typical in traditional RDBMSs. Something like this: row format, delimited, fields terminated by comma. Okay, if we do this, I can just copy that file into this location and I should be able to query the data without any issues. Okay. So here I will be recreating the table. We can drop the table. Drop table orders and then recreate this table. Now the table is created. Now if I say display formatted, you see here field delimiter is comma. Okay. Now what I can do, I can just say, so there is a command called DFS in Hive, which is similar to Hadoop FS. Okay. Either to copy data from one location to another location in HDFS, we can use DFS-CP and then say public retail DB orders, and the target location is this one, and it will copy the data from this location to that. That is one way of doing it, but more formal way of doing that in Hive is nothing but running a command called, this is Hive command. Okay, load data in path public retail underscore DB orders into table orders and hit enter. No. Okay. There is not so this, when we actually say load data in path, it will actually move the files it will try to move the file from this location into this table. As the user training have only read only permission on this location, it is failing. Okay. We have the same data on local file system also. So if you want to copy from there, we can say load data local in path, and then we can give local directory location. Okay. So the local location is /data/retail/db/orders into table orders. Now the data is copied. Okay. So this is more formal way of getting data into Hive tables. And then if you want to just query, you can say select star from orders. To just preview first 10 records, we can say limit 10, and it will get the data. And if you see, it is showing null. The reason why it is showing null is when we actually create the table, we define order date as date. In Hive, the proper format of date is only YYY-MM-DD, but our input data have timestamp also. That's why it is failing here. To fix this, we have to drop this table, and here instead of date, let us use string and then recreate it. Okay, so string can store data in any format. Now, if I copy data again, and if I see the results, now we got the data. Okay, so this is how you can load the data. You can also insert, update, delete, but there are many restrictions on the data. It is not that straightforward to insert or update or delete as we see in traditional databases. In traditional databases, CRUD operations are very, very important, but here row level CRUD operations are not that important, and it's not that simple also. There are so many hidden complexities, which I will be covering a lot more in detail when we actually get into Hive. For now, we just saw how to create a Hive table, how to load data into it. And also let us take an example of a bit complex query. Let's say I want to get number of orders within each state. we can say select order status. The same query which we can run um, in traditional RDBMSs will work here. From orders, group by order status. Like that, starting from simple queries like this, you can go up to the analytical queries also. Okay, so we'll see that as part of the main agenda of Hive. So that's what I will get into those internal details later. Okay, for now, just focus on how to create the table, how to query the data from the table, etc. Don't worry about um, how the data will be actually stored and all. I will explain at a later point in time. Okay, there are so many things which you need to understand. You need to understand the architecture of Hive. You need to understand where this metadata is stored, where the files are stored, and how to override the behavior by resetting the properties. All these things will be covered as part of the main module of Hive. If you go through the curriculum, one chapter is dedicated to Hive, and it will take at least 3-4 classes or even more to complete Hive in detail. Okay. So in this case, when I say load data in path, it try to move data. Just having read-only permissions are not good enough. The user who is trying to move also should have write permissions. When I say move, if you run load data in path like this, it will remove the file from this location and it will copy into the location of the table. As the user training does not have the permission to move this file from this location to orders location, it was failing. Okay, and can you guess why it is trying to move rather than copy? I have already explained why it is trying to move rather than copy when I try to run load data command to get data from HDFS location into Hive table. No. Anyone from online? Why they are actually moving the files rather than copying? It's not same directive. You are actually moving from public retail DB orders to whatever location the table is pointing. Okay, so table is pointing to this location. Table is pointing to this location. So when I say into table, it actually copies the data to this location. Okay, so why it is moving rather than copying? Yeah, the answer is performance. So it's very important for you to understand the question. The answer is performance. If they have to copy, they have to create new set of blocks and then they have to place it in HDFS. With move, they just have to reset the metadata pointers. They don't need to actually copy the files. So for performance reasons, it is actually they have decided to move rather than copy. Okay, so typically when we do this kind of stuff, we will be dealing with huge amounts of data in HDFS. Okay, as the data volumes are high, they are trying to improve the performance as much as they can without exposing to you. Okay. Yeah, we will lose the data in original location. That is the side effect of it. Yeah. So I think Shiva, I already responded to you. For whatever we have covered with respect to HDFS and YARN, the content is not very important except for HDFS commands. The reference material is not very important. They are all theoretical. There are not much code snippets and all those things. but still we are working on coming up with the content with a very high level pointers. But as we proceed further with respect to Hive, Spark, etc., we will take care of creating the content immediately after class is done. Okay. The reason why we are a bit laxed on HDFS and Yarn, or especially with respect to Yarn, there is nothing much uh, to document rather than explaining the theoretical aspects of it. Okay. So going forward with respect to Hive, Spark, etc., you will be seeing a lot more content. Scala fundamentals, I think we have covered as much as we can. Let me see. I think Python is not that much, but Scala, we have covered most of the things. I will check with my team and let's see. Yeah, for most of the things, we have the material. Okay, this one is missing. I will talk to my team and get these things done. Okay, even with Python. Any other question before we move on to the other one? Okay, so now okay, I will take questions for today. We'll wrap up for today because we have to start a new topic like pig, and I will be doing tomorrow. So application manager. So there is nothing like application manager. There is only resource manager. There is only resource manager and node manager, which will be running all the time. Okay, if they are down, that means uh, administrators have to fix it immediately. They are supposed to be running all the time. And then whenever job is submitted, there will be application master created. Okay, so there is no term called application manager. It is incorrect. Or I'm not sure. I'm not aware of such kind of terms. Okay. Now the question is how many application master can be there? For each Spark application or MapReduce job, there will be one application master running on the cluster. The way you can get those details are you can run yarn application list. Sorry. Or you can go to resource manager UI and you can click on running jobs. And for each of these jobs that is running at a given point in time, there will be application master associated with it. Okay. So if I go back to this Excel spreadsheet, one thing you need to understand is if 17,600 are the number of tasks that are required, then the capacity that is required to run the job is 17,600 plus 1. That one is for application master. Similarly, for job 2, when we say 10 to process the data, we need one more task, one more container for application master. For each and every job or Spark application, there will be application master associated with it. And it takes the capacity of the cluster only. So in this case, the actual capacity of the job is not just 17,600, but 17,601. And that one is for application master. Good question, Kamlesh. Yeah. So any other question? Okay, then we'll catch up tomorrow and see you. Bye.